back, children. In this video we are going to solve questions of exercise 7.1. Let's see the first question. Here it is given, find the distance between these 2 points. So distance is to be calculated. We know distance formula is written as under root x1 minus x2 whole square plus y1 minus y2 whole square. So consider this point as your x1, this point as your y1, this as your x2 and this as your y2. You just put the values over here. So what is your x1? Minus 5. So minus 5 minus what is your x2? Minus 1. So this minus and this minus will become plus 1 whole square plus y1 is your 7 minus 3 whole square. On simplification it will give me minus 5 plus 1 is 4, minus 4 and minus 4 square is 16. 7 minus 3 is again 4 and 4 square is 16. So this is giving me under root 32, or simply this can be written as 16 into 2. 16 is a perfect square, so can be taken out of under root sign, and this is your distance. See the next question, children. Here it is given, determine if the points this, this and this are collinear. Children, this question can be done by two methods. This can be done either by distance formula or can be done by area of triangle formula. Let's see it first with the distance formula. So this is, suppose your A, this is your point B and this is your point C. Now, let's suppose these points are collinear, A, B, C. Then the condition for collinearity is written as condition for collinearity is sum of these two distances, that means sum of AB and BC should come out to be equal to sum of this AC distance. If these two are equal, then we can say that the points are collinear, and if they doesn't come out to be equal, that means the points are non-collinear. So let's see whether these are collinear or not. First of all, you need to calculate AB. AB distance, when you are calculating AB distance, let this be your x1, y1 and this be your x2, y2. And you will be applying the same distance formula. So for AB, I am writing it as x1, which is 1, minus x2, which is 2 whole square, plus y1, which is 5, minus y2, which is 3. So this is your AB. Then plus for BC, you take this again as x1, y1 and this as your x2, y2. So here it should be under root x1 is your 2 minus and minus 2 will become plus 2 whole square, plus what is your y1? 3. It is minus 1, so it will become plus 1 whole square, equal to under root AC. That means you need to take this one as x1, y1 and this one as x2, y2. So here it will be 1 minus minus 2 will make it plus 2 whole square, plus 5 minus minus 11 will make it 11 whole square. So let's see here, this is 1 minus 2 will be minus 1 whole square will be just 1, plus 5 minus 3 is 2, 2 square is 4, plus this is coming out to be 2 plus 2 is 4, 4 square is 16, plus 3 plus 11 is 14 and 14 square is 1, you can say 196, equal to under root, this is 1 plus 2, 3, 3 square is 9, plus 5 plus 11 is 16 and 16 square is 256. So here it is root 5 plus under root, this will be 6 and 6, 12, 11, 212. This equal to under root 9 and 6, 15, 6, 265. Now children, these are not like terms, so cannot be added. And here it is under root 265. So this plus this is not equal to this. Therefore, A, B, and C are not collinear. Let's see this solution with area of triangle formula. We know area of triangle formula is half x1 and then you write bracket x2, then again you write a bracket x3, then again you write a bracket. Since you have taken x1, you will be taking here as y2 minus y3. You will not be considering y1 over here. For x2, that means you have end up at y3, so y3 minus y1. Here it is x3, so I will not be considering y3. I will be taking it as y1 minus y2 because I am already on y1. So let's put all these values over here. So how you are going to consider the values? Say this will be your x1 y1, this will be your x2 y2, this will be your x3 y3. So let's put the values. This will be half. x1 is 1, y2 is 3, minus y3 is minus 11, so it will be plus 11, plus x2 is 2, y3 is minus 11, minus y1 is 5, plus x3 is minus 2, so it will be minus 2, y1 is your 5, minus y2 is your 3. So these are the things which you have put. Now here it will be just half. 3 plus 11 is 14, plus 2, this will be minus 16, minus 2, and this will be your 2. Let's solve it. So this will be half. 14 minus 32 minus 4, which will give me half of 14 minus 4 is 10. 10 minus 32 will give me minus 22. But this is in mod, that means it will be in positive. So 2 into 22, which gives me 11. Now if it doesn't come out to be equal to 0, if it doesn't come out to be equal to 0, that means it is forming a triangle. It is forming, that means it is not equal to 0, that means it is forming a triangle, hence the points are not collinear. For collinear, this should come out to be equal to 0. Now let's see this question, children. Find the point on the x-axis which is equidistant from this and this. Children, wherever a diagram is possible, you draw the diagram. So here it is given, find the point on the x-axis. That means you need to find out this point which is lying on the x-axis, which is equidistant from this and this. That means two points are lying somewhere. Let's suppose these two are the points. One is given to you as 2 comma minus 5. Although I know that 2 comma minus 5 will not lie here, but this is a rough sketch. So say this 2 comma minus 5, I am taking it here, and this is your minus 2 comma 9. Now these two are equidistant. Equidistant means these two distances are same. So this point is lying on x-axis. I know that coordinates will always be written in the form x comma 0 because on x-axis y coordinate will be equal to 0. So let this be A, this point be B, and this point be C. So what I need to find out, or what is given in the question, it is given that AC equal to BC. The distances of these 2 points are same from this point. That's why I have written AC equal to BC. So let's write down the values over here. AC is the distance. So x1, say this is your x1 y1 and this is your x2 y2 in this case in AC. So x1 is 2 minus x whole square plus y1 is minus 5 minus y2 is 0 whole square. So this is the value of AC. What is your BC? Under root, let this be x1 y1 in this case. So here it will be minus 2 minus x whole square, x1 minus x2 whole square plus y1 minus y2 whole square. Now you solve it. We can square, we can take take square on both the sides. So it will be 2 minus x whole square plus minus 5 whole square will be just 25. This will be, again, minus I can take common and minus square will be plus only. So here I'll just get 2 plus x whole square plus 9 square is 81. Let's open it with the formula a minus b whole square and a plus b whole square. So a square plus b square minus 2ab plus 25 equal to a square plus b square plus 4x plus 81. Now this x square and x square gone, this 4 and 4 gone, this 4x, or I can take this 4x this side, so it will be 8x equal to, this will be here 25 minus 81. So I'll be getting as, subtract these two, so I'll be getting it as 7 minus 2, 56, minus 56 equal to 8x, and x will be equal to minus 56 by 8. So x is your 7, minus 7. So the point, the coordinate is, or I can say the point on x axis is x comma 0, that means minus 7 comma 0. Let's see this question, children. Here it is given, find the values of y for which the distance between the points P and Q. That means P and Q are 2 points and the distance between these 2 points is 10 units. So the point P is given as 2 comma minus 3 and Q is given to you as 10 comma y. That means you have PQ equal to 10 units. So PQ is the distance, so I can apply that distance formula here. This is your x1, y1, this is your x2, y2. I can put the values here. So x1 minus x2 whole square plus y1 minus y2 whole square equal to 10. I can take square on both the sides. So squaring both the sides, I will be writing it as squaring both the sides. We get, this is 2 minus 10 is minus 8, minus 8 square is 64. We are squaring it, so under root gone. Here it will be just plus, minus I can take common and minus square will be just plus. So it can be written as 3 plus y whole square equal to square of 10 will be your 100. Now you can open it by the formula a plus b whole square. So this is 64 plus a square plus b square plus 2ab equals 100. So I'll be getting it as y square plus 6y equal to, this will be your 71, and 71 when goes this side it will be minus 71. Subtract them, so it will be 29. Now here I am getting this as y square plus 6y minus 29 equal to 0. 9 and 4, 73. So here I'll get it as 27. So this is 27 over here. Now you have got a quadratic equation over here. You can solve the equation either by quadratic formula or by prime factorization method. So 27 is given to you. I can write it as 9 3s are 27, and here I want plus 6. So 9 minus 3 is plus 6. So y square plus 9y minus 3y minus 27 equal to 0. Y can be taken out. Y plus 9 minus 3 can be taken common. So again y plus 9 equal to 0. Y plus 9 is again common. So y minus 3 equal to 0. That means either y can take the value minus 9 or y can take the value 3. And in the question it has been asked, find the values of y for which the distance between the point is 10. So y can be minus 9 also here. Y can be minus 9. That means the coordinates can be 10 comma minus 9 or it can be 10 comma 3. So these are the points over here. Children, you can expect these questions in your boards. Let's see this question, children. Here it is given, if Q is equidistant. Let's suppose this is your point Q. This is equidistant from P and R. That means these two distances are same. The point is given to you as 5 comma minus 3 and R is given to you as x comma 6. Find the values of x. So simple. What do you have to do? Here it is given that distance of PQ is equal to QR. Here the value is given to you. This is your x1, y1. This is your x2, y2. So simply you can find out distance PQ and here you can find out distance RQ. So after solving it, I will get it as, you can pause the video and see the solution. Now children, it has been asked also find the distance QR. So this is your QR, that means x square plus 25 is your QR, and your x square is 16 plus 25 is equal to QR, and this will be your 41. So QR is your 41. Find PR. If you want to find PR, join this line. This will be your say x1 y1 and this will be your x2 y2. So you find out PR yourself by writing it as 5 minus x whole square plus minus 3 minus 6 whole square. Now you know the value of x, so you write down here plus minus 4. One time you write it plus and one time you write it 4. One time you will take x equal to plus 4 and one time you will take x equal to minus 4, and you will get two distances of PR. If this r is on this side, then you will get a different length. See this question children. Here it is given, find a relation between xy such that the points xy, so let this is your point xy, equidistant. That means these two distances are equal. Say this point is 3, 6 and this point is minus 3, 4. So let this point be A and this point be P and Q. That means it is given PA equal to AQ. So I will be writing my distance formula. Here it will be x1 minus x2, so x minus 3 whole square plus y minus 6 whole square equal to AQ is what? X minus minus 3, which will make it plus 3 whole square, plus y minus 4 whole square. I can square both the sides, so squaring both the sides and simplify it. So I have just simplified it. Here I have applied a minus b whole square, here I have applied a plus b whole square, and I have simplified and got the answer as 3x plus y equal to 5. So this is the relation between x and y. You can pause the video and see the solutions. Children, in this exercise we have just taken use of distance formula. So just basically using distance formula we have finished this exercise.